Hey Meredith, this may not be my best attempt ever. I'm sitting in the dark at my house, but here we go. So I'm just drawing out that's a little 6-degree slope. We got our bobsled, and that's 22 kilograms. And we have this distance here, 75 meters. I'm going to start writing down some equations as you've seen me do in the past. I'm going to just say, all right, we got the force of gravity, that's mg, and if we plug in 22 and 9.8, we get 215.6, and that's in newtons. Let's do another little diagram. We'll think about something going on here. We got the pushing force. By the way, the pushing force is the guy's pushing it all the way down the slope. That's not entirely clear in the way the question was worded. We've got the parallel force, and that's the force of gravity that's helping to, that's the force of gravity that's pulling the thing down the hill. We got them going against that is the force of friction. And what else do we know? All those three things combined, that's the net force. And we're going to use that to find the acceleration. All right. Now, in this problem, we don't know. We don't know the time. When that happens, we often are stuck with, in our, whatever you call them, your motion equations, we're often stuck with this one. The final velocity squared equals the initial velocity squared plus 2 times a times d. Well, we know the final velocity needs to be, 60 kilometers per hour? And that's equal to 60,000 meters over 3,600 seconds. And that comes down to 50 meters every 3 seconds, just as a, reducing that fraction. The initial velocity is 0. Oops. And d equals 75. So we can plug all that junk into that equation, and we can solve for a. And what we're going to get, you can do this on your own. You can follow this because, we have everything except for a in this equation here. So if we solve that for a, we get that a is equal to, I'm just being weird, I'm doing this all in fractions, but 50 over 27. So this is an important result for us. That's what I think you said was holding you up on solving the problem. Let's do some more drawing. And that is 90 degrees. This is 6 degrees. And I'm going to go ahead and do what I did before. I'm going to orient my three forces. Force of gravity pulling straight down. The normal force. Same orientation it should have as the slope. And finally, the pulling force, or the parallel force, going down the hill. Now these are all, we can draw little trig equations here. The normal force equals mg cosine 6 degrees. The parallel force, that's the force of gravity, the part of it that is helping pull the bobsled down the hill. And that is mg sine of 6 degrees. Finally, the force of friction is mg mu cosine 6 degrees, because the force of friction in general is just going to be, I don't know why that thing is, that pointer is off. But it's the force of friction is mg mu, and then the cosine of theta. Well, it's the normal force times mu. All right, let's keep going here. We know now that F sub net equals ma, and we know both of those things. We know that mass is 22 kilograms, and the acceleration is 50 over 27, as I wrote right here. So that's enough to solve for to solve for F sub net. And F sub net equals 40.74 newtons. Then F sub net, I'm going to see if I can finish all this on this page, it doesn't really matter, equals 40.74 equals F sub push, which we don't know, that's what we're trying to solve for, plus the parallel force, and minus the force of friction. So I can plug in for the parallel force. You can calculate that on your own. I don't think you would have any trouble doing that. That's this equation here. So I'm gonna give a value for that, and then I'm gonna put that here for the parallel force, and then the force of friction. This one here, you can solve for that. And that is going to give me, this is what we don't know. But I know that I got this written out on something else, so I'm just trying to, okay, so then the parallel force, you should get that that's equal to 22.54. The force of friction is 21 point, these are all in newtons, 0.44. And then we're just solving for, how did I mess that up? This should be 40.74. And if I solve that for the pushing force, you can send me, if you have any questions about what I'm doing here, send me another text or email. But that's enough information for us to say that the pushing force would have to equal 39.64 newtons. All right, Meredith, that is that. Hopefully that helps you. Okay, I'll talk to you later. Bye.